Hello, good morning to all. Can you hear me?
Good morning, sir.
A very good morning, very good morning. So, yeah, good morning, good morning, good morning. Yeah, so we'll start our class. Mhm. Yeah, let me call some. Then, okay, then we'll start our class. So, yeah, today we're gonna learn about right circular cone. Okay, so today topic is write it down in your copy. Right circular cone. Now, cone is gonna look like this, like a birthday cap, This is gonna be like a cone. Yes? Now, the cone has the radius part, the height part, and one more thing is there, which is slant height. This is slant height. Slant height is like if we are making cone. So cone, the hypotenuse part height is called as the slant height. So I'm repeating again. The cone has this in this shape, in which it has circular base, okay, a height which is represented by h, and a slant height which is represented by l. Okay, okay. So for find the slant height, the formula is L square is equals to h square plus r square for finding the slant height, where L is basically slant height, h is basically the height, and r is equals to radius. Okay, did you understand? Yes or no? Did you understand, guys? Abigail, your mic, can you unmute it?
Sorry, sir.
Did you understand, guys? Okay, this is how you will find a slant height. Now, there is a formula for the CSA. CSA, which is also called as curved curved surface area. The formula is pi r l, where pi you can use as 22 by 7 or 3.14. Okay, and PSA,
Or is it pi r
which is
square? What is that
pi
square?
r
Is it
l,
pi?
pi r l. TSA, which is also called as total surface area. So in that total surface area, what we are going to do, pi RL basically denotes this thing, This thing is basically called as pi RL. Okay, the curved surface area in which we are not including the bottom circular part. Understood, guys? Yes or no? Bottom circular part is not included in that. And for the bottom circular part, what we need pi RL plus pi r square, means the bottom circular part area, which is pi r square. So it will become what? Pi r will be the common, and the L plus r will be the remaining behind. So this is total surface area. Now for the volume. So it is seen that the, like for example, if I am making cylinder, and inside that with the same base, same radius, if I will make a same height cone, then it is seen that like this cone is basically actually one third of a volume of cylinder. So it is said that same radius and same height volume of cylinder is equals to, no, volume of cone, sorry, volume of cone, oh, is equals to 1 by third of volume of cylinder. Basically, what is the volume of cone? So volume of cone, what is the volume of cylinder? Pi r square h. So 1 by 3 pi r square h. This is the volume of cylinder. Did you understand? Yes or no? Yeah, write it down quickly.
Can you repeat the volume thing again, sir? Didn't understand.
See, the if you will see the cone and the cylinder part, so you will find it out that one third of a cylinder volume is basically a cone. Okay, so the volume of cone is equals to 1 by 3 into volume of cylinder. And what is the volume of cylinder? Pi r square h. So I just replace with the pi r square h. Do you understand, guys? Okay. Shall I raise this?
1 minute, sir.
Abigail, will you attend science class today?
Yes, sir.
Okay. So you saw the previous two classes video?
No, sir.
No.
Actually,
Okay.
sir. Actually,
Huh?
sir, my mother said, right, I was actually doing class with another person.
Hmm.
So they are also doing the same topic.
Okay.
So I attended those two classes. But I have lot of doubts in that.
Okay. Okay. So we'll go for the doubts.
Yeah, sir. And one more thing, in the homework of day before yesterday and yesterday, I have some doubts.
Yeah. So first, let me do some questions on it. Then we'll do the doubts.
Okay, sir.
Okay. So I'm erasing this. Okay, so we will do one question based on it. So for example, this is a cone and the radius is given as 7. The height is given as 24. So the question says calculate first slant height, second CSA, third TSA, and fourth volume. So how will you do this, guys? Do you know how to do this? Jahoan, Abigail? Okay. Sam, you know?
So it is 24 the slant height, sir.
No, it's normal height. This height. Slant height, there's a formula. What's the formula, Sam? Right now you wrote. What is the formula for finding slant height?
Uh, L is equals to squared height. L squared is equals to wait, uh,
H square
yeah,
plus
height
R square.
height
So
square plus R square.
you yeah, so you know 24 square and 7 square. Can you do it and can you find the slant height and tell it to me? Yeah, quickly do it.
One second, sir. My dog ran off with my pen, sir. One second.
Done, everyone? Everyone got it?
624, sir.
625, first of all. So you got L square as 625. Okay. Now this square will go to the other side, it become root. So L is basically equals to root of 625. And if you will find the root of 625, it will be 25. You know how to find the root of 625, Sam?
Divide, sir.
No. How to find square root? By the prime factorization, no?
Yes,
Like
yes.
2625, then we have to make pair of 2. Remember? Or you want me to understand it to you?
Can you just do one example?
Like for example, 625 is there. Okay, so 625. Then you will take that which table it come 5. So 125, and then 5 divisible. Then it become 25. Then it will become again 5. Then 5, and then 5, and then 1. So it means that L root of 625 can be written as 5 into 5 into 5 into 5. Now I will make the pair of 2, 2. Out of this, only one 5 is allowed to come. So L is equals to 25, like this. Understood? Okay. Hannah done? Hmm. So yeah. So today's homework is example 21 point. I will write it down. Hannah, did you check how much chapter is left?
Yes, I put it in the group, 2 chapters.
Including this?
No, after this is over, then chapter 16 and 19 is.
Okay. And this one, sorry, Jahovan, did you check in science how much is left?
No, sir, I'll do it today.
Okay. Okay. So this is your homework. Write it down in the top right. Okay. Only 5 questions are there in check your progress. So please do it. Now we'll come to the doubts. So yes, Abigail, tell me your doubt, please. I'm erasing this. Okay. Yeah, please. Sam, did you understand the cone concept?
Sir,
Good.
actually, I
Yeah.
think so.
Sorry.
Yes, yes, understood.
Yeah. Abigail, please.
Yeah, sir, and check your progress 21.1, the fourth question.
21.1.
1.
And the fourth question.
I don't understand, like, what does the thickness of the wood have to do with the volume?
Okay. So basically, like for example, there is a external dimension is there. If I will tell you, it's gonna be like this much thickness is there. Can you see my video? So this is external diameter, or we can take one more example. We can take one more example like this. Like, can you see the thickness? Thickness of this? Huh? So this is very less thickness, but sometimes it is very much thickness is there. Okay, so it's gonna be like this. If I will tell you, so I'll write the diagram. So for example, I will tell you like this. So for example, this is a normal cuboid. Okay, and if you will see this face from upside, so it's gonna be look like this. like this. Like this is 1 centimeter, and this is also 1 centimeter. Okay, thick, like thickness. Okay, Abigail. Oh, where she went? So yeah, what was I'm saying? The external diameter which is given, okay, it's basically thickness. So the thickness, like for example, if you will take out the length, the external diameter of the length is given 42 centimeter. And if you want to find the internal dimension, so what will you do, Hannah? What will you do?
Find the internal volume.
Yeah, how will you find the internal volume in this case? The thickness is given 1 centimeter, and the external is given as 42. So okay, so internal dimension will become
42 minus 1 into 2. So 40.
yeah, because 1 centimeter from here it will deduct, and 1 centimeter from here it will deduct. So it means that the internal become 40. Understood? Yes or no? Did you understand? So in the same way, every like the length which is 42 centimeter, you have to minus 2, because 1 centimeter will come na, like this. So it becomes 40 centimeter. In the same way, breadth which is 32, no? Yeah, 32 minus 2, which will become 30 centimeter. And height, basically it is 27, so it will also minus by 2, which is 25 centimeter. So you got the internal dimension. Now you have to multiply it to get the volume. Understood, Abigail? Sam?
Yes, sir, got it.
Can you explain the last part is done?
See, first we have to find the internal dimension. An internal dimension can we find it out by minus is by 2. Why we are doing minus? Because thickness 1 centimeter is there. So 1 centimeter it's thick from this side also, and 1 centimeter is thick from this side also. So it became 2 centimeter basically. So 42 minus 2 become 40 centimeter. We got the internal dimension, and we have to use the formula of volume of cuboid. What is the volume of cuboid, Sam? What is volume of cuboid? Yeah, you can check it. Quickly tell me. Shall I sleep?
Length is the breadth of height.
Yes. So length we got 40 centimeter, breadth we got 30 centimeter, and height we got which is 25 centimeter. Did you understand? Yeah. Next, please, Abigail.
Yes, sir. The eighth question in check your progress 21.1. So in this, I just have a doubt. Like it's saying the wallpaper which they want to stick on the wall is 75 centimeter wide. So should I like calculate how many times the wallpaper fits into the length and the breadth of the room? Is that what they're asking me to find?
Can you repeat your doubt, please?
Yes, sir. So they gave the dimensions of the room and they're
Hmm.
saying stick a wallpaper in it, and the wallpaper has a width of 75 centimeter. But the length of the room is 6 meter and the breadth is also 5 meters. So should I see like how many times 75 centimeter comes inside 5 meter and six
No,
meter?
no, no,
Is that
no.
what they're asking me to find out?
No, 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 no. It's not like that. It's not like that. Okay, so first of all, we have to find the area of room. Okay. Yeah, we'll do it on the paper. Just give me a second. See, it's very simple question. It's not that much hard. See, a wallpaper, this is a length of the room. The doors and window occupy this much space. Find the cost of paper remaining on the portion of wall is the 75 centimeter wide. So it's gonna be like this. We have to only put it on the walls. Okay, only put it on the walls. Yes. Okay. So how will you do this? See, like for example, this is a cuboid. Okay, and we have to put this roll around the walls. So we are using this paper, and the dimension it is given that it is 75 centimeter, this much wide, and we have to find how much length we have to apply on it. Okay, so we should know that LSA of cuboid is equals to the area of a paper. Like whatever the paper will be there, remember this thing, whatever the paper will be there, okay, it is applied in the room. It is applied in the room, na? So whatever the paper is there, it is applied in the room. It means that the length into breadth, the area of this paper is equals to the four walls area. Did you understand? Yes or no? So now what is the LSA of a cuboid? 2, अरे यार क्या हो रहा है आज ये बहुत. Yeah, 2h is equals to L plus B is equals to area of paper, which is length into breadth. Okay, and did you understand? Yes or no? So
Yes.
2h into L, which is 6. I will write h also. 2 into 4 plus 6 plus 5 is equals to length, I don't know, and breadth, which is 0.75. Why I take 0.75? Because 75 centimeter is given. I have to convert it into this. When you will solve it, you will get the length and you have to multiply it simply with 2.4.
Okay, okay.
Okay? Yeah.
Okay, so they're just asking me the length of the wallpaper needed, that's all.
Yes.
Okay.
And when you find the length, you have to multiply it by 2.40 so that you can get the total cost.
Okay, so got it.
Yeah, next question, please.
Yeah, so in chapter 21.2,
Hmm.
that fourth question,
The length and breadth
they're
of
asking,
the.
yeah, so they're asking for the volume. For that, I first need to find the radius.
Hmm.
So I solved it by taking the circumference. Like circumference
Hmm.
equals to 16 meter.
Yep.
So, but I'm getting radius as 0.02 centimeter.
Let me take one paper for you. Where's that paper? Just give me a second. So here I have paper for you. Okay. Now we'll take this. Can you see me? Yeah. This is okay. This is 16 centimeter. Okay, and this is what 33 centimeter length. Now it is folded about its breadth. Means it is folded like this from its breadth. Understood? So the circumference will become 33.
Oh, okay, got it. When they said by its breadth, I thought like they were folding the breadth into half and then they got one cylinder.
No.
Okay.
Okay. Yeah. Next, please.
Yeah, so got it. Next one is the sixth one.
Yeah.
One minute, I'll take the question. Yeah, and the sixth one, I don't understand what the question is saying, and I don't know how to do it.
Okay. Good. Okay. This is the question that we are doing. Sam, are you there with me?
Yes, sir. Sorry, my camera.
Yeah. So basically, there is a hollow cylinder. There is a hollow cylinder like this. Okay. Now, a hollow cylinder has the metallic cylinder is open to both the ends of its length 8 centimeters. So the 8 centimeter is the height for both the cylinders. If the thickness is 2 centimeters, so it means that this is 2 centimeter and this is also 2 centimeter, and the external diameter is 10 centimeter. So the external diameter is 10 centimeter. Okay, so external diameter is 10 centimeter. Find the whole curved surface area. Find the whole curved surface area. So basically, you should know that, for example, if external diameter is 4 centimeter, then what will be the internal diameter? Can you tell me, Abigail?
That will be 6 centimeters.
Sorry. If external diameter is 10 centimeter, then can you tell me what is the internal diameter?
Yeah, sir, 6 centimeters.
Yeah, 6 centimeter. So if internal diameter is 6 centimeter, so external radius will be, what will the external
5,
radius?
5
5.
centimeters.
And what is the internal radius?
3 centimeters.
Yes, 3 centimeter. And the height will be same for whole.
Yeah, sir.
Yeah. And now it is said that it is open from both ends and open. Like there is no circular things are there. So what we have to find? CSA. So CSA of whole cylinder is equals to CSA of external cylinder minus CSA of internal cylinder. Did you understand? Did you
No,
understand?
no,
See,
I think.
external cylinder, we have to tell the CSA. Okay. When you will subtract, first we have to find external cylinder. External cylinder means external diameter one. So what is the CSA? Pi r square h.
Yeah,
Yes. So
yeah.
pi into capital R into h, which have same, minus pi into small r into h. I will take out pi and h as a common, so it is capital R square minus small r square. Did you understand? Now,
Like I understand why it's coming like that, but I don't understand why we should take CSE of external cylinder minus CSE of internal cylinder.
Because it's normal. It is not a normal cylinder. It's a hollow cylinder. Hollow cylinder is gonna be look like. If I will give you one example of hollow cylinder, do you know pipe? Garden pipe.
Yeah.
If it is very thick, if it is very thick, okay. So how will you find? If it is very thick, then how will you find? You have to subtract the external minus internal, okay, so that the surface area you can get will be the CSA of a whole cylinder.
Oh, okay, got it.
Okay, because of the thickness we are doing this thing. If thickness is
Hmm.
not there, if normal cylinder is there, then it's easy, but we have to do it because of thickness.
Okay, so
Okay,
got it.
yeah, next doubt.
That's also
Okay, everyone, anybody has any doubt? Jahovan?
Answer. In that half yearly exam, the question number 1, actually.
Half yearly exam question number one. Half yearly exam, you said?
Yes.
Mm, let me check the half yearly exam paper. The question number one. This question, no? Okay.
Yes.
Okay. So we know that a plus b whole square is a square plus b square plus 2ab. Okay. Now a plus b whole square, which is like a plus b value is given, which is 12. So can I write substitute the value of a plus b as 12? So it becomes 12 square plus a square plus b square plus 2 into ab, which is 22. Can I write it like this? Did you understand, Jehovan? No. Means the ab value I substitute as 22 and a plus b I substitute as 12. So it will become 144 is equals to a square plus b square plus 44. It will go and it will subtract. So 144 minus 44 is equals to a square plus b square. So a square plus b square is equals to 100. This is the answer. Understood? No, Jehovah.
So then why did they provide the AB for 20? Oh, sorry.
They provide AB is equals to 22 so that I can.
So I thought that we were supposed to figure out which is A and which is B, and then only get the answer.
No. We can't do that like that. We have to just substitute the formulas into the formula. Okay. So we'll stop here only. We have 4 minutes break, then come back in science class. Till then, bye, Hannah. Yeah, Sam, come in 4 minutes.
And how this way?
Yes, please.
Sir, I'll just leave the classroom. I'll come back in 4 minutes. Sir. I'll join back.
Yeah. Okay. Okay, guys, come back. Come back quickly, please. Yeah. Yeah. So first we'll take out the Abigail's doubt, then we'll move to the next topic. Yes, Abigail, please. Doubt, please. Hello. Can you hear me, guys? Hello. Hello. Can you hear me? Am I audible?
Yes, sir.
Yes. Turn on your camera, everyone. Abigail, are you there? Hello, Jashron. Good morning.
Good morning, sir.
Very good morning. Abigail, are you there? Can you hear me? No? Okay, so we'll move forward. Sam, turn on your camera, please. Okay, so we were doing this. We did this. Okay, write one question. Okay, I will write the question and then you have to solve it. Calculate work done if 3 coulomb charge is moved with potential of 24 volt. Okay, so how will you do this? How will you do this? Calculate the work done if 3 coulomb charge is moved with a potential of 24 volt. How will you do it, Jehovah?
We use the formula V equal W by Q.
Yeah.
Case V is 24, Q is 3.
Hmm. Good. So yeah, Abigail, you learn this thing? Did you learn this thing?
Sir, I was there in the class when they taught me, but I didn't understand it.
Okay, you didn't understand it. Okay, so did you understand the Coulomb force?
I know what a coulomb is, but I'm not sure I know what a coulomb is.
You know Coulomb force. I mean the concept wise and everything wise.
Coulomb is measure for charge, right?
Yeah, but what is Coulomb force?
I don't know, sir.
Okay, do you know what is charge body? How it charge came into the body?
Yeah, like when two bodies collide or rub against each other.
Okay. Okay, so we'll take a small revision. Okay, so basically, what is a charge? Like how a body develops a charge. So when you're rubbing it, so it gets the charge. But how? So in the first class, I told you there are protons and there are electrons. Yes. So protons and electrons are always revolving around the protons. Okay. Now, like for example, if I'm rubbing, can you see my video? If I'm rubbing this material with the paper. So what happening, because of the rubbing, there is a transfer of electrons. So for example, when they are neutral right now, they are neutral, but when I'm rubbing it, okay, so this become negative charge and this become positive charge. Why? Because the electrons in this object is now transferred into the paper, makes it negative and makes it positive. Understood? Yes or no? So
Yes.
basically, the Coulomb force is this thing only, that Coulomb force is the force between the charges. Like for example, this is first charge and this is second charge. Okay, so Coulomb force is a force which is between the charges. Now, for example, if both are plus, if for example this is also plus and this is also plus, so they will have force of attraction or repulsion.
Repulsion.
Yeah. So they will have force now. They will have force now. And if I will make this is as plus and this is a negative, so they will have what? Negative force of I mean attraction force or positive repulsion force.
Attraction.
So basically, what was I'm trying to say? Like if two charges are there and they kept distance r away from each other, so they will have force of attraction. That force is directly proportional to the product of their charges. Product of their charges. For example, if I will take here as this as 2 and this is as 3, so it will be 6. And if I will take this as 100 and another one is 200, so it will be 20,000. So it means that more the charge, more the attraction will be there. For example, small magnet, small force of attraction; big magnet, big force of attraction. In the same way, the product of their charges, if the product of the charges, in the first case we are getting 6, they will have force of attraction but little. But in the second case, we are getting 20,000. They will have a force of attraction. It will be gonna be very big as compared to the first case. Understood? And R is the distance of separation. R is the distance of separation. The force is directly proportional to the product of the charges, and force is indirectly proportional to the distance between them. Okay, and when you will solve this first and second, so you will find it out that force is directly proportional to the capital Q into small q, but indirectly proportional to the r square. Did you understand? And
Yes.
when you will remove the proportionality sound, you will get k q q by r square. This is basically the Coulomb force, in which F stands for force, capital Q stands for charge, any charge, small q stands for another charge, r is the distance of separation, and k stands for 9 into 10 to the power minus 9 Newton meter square. Like this. Newton meter square, C2 minus. This k is a proportional sign which is called as constant. It is always fixed. It is always fixed. Did you understand now Coulomb force?
Yeah, sir. So I have one doubt. This
Please.
proportionality constant K, is it also
Hmm.
used for other other calculations like I don't know, gravity also we have one constant K. Is that the same thing?
So that's like, for example, force is equals to kma. In your book, if you will see the force, like force is directly proportional to the mass. Force is directly proportional to A. So force is directly proportional to mass into A. And if you will remove the proportionality sound, it will become kma. And in that case, the value of k is 1. So in each case, the k values differs. It's not same in all the scenario, because all have different values, different aspects, different quantities. Na? So in the same way, the value of k is not same in all the scenarios. Okay, in the gravitational small capital G is there. So it also has different values because this is comes under the electrostatic energy, that is come under the gravitational energy. Both have different aspects. We will learn in that also. Yeah, please. Anything else? Abigail, are you there? Is she there? I guess she got together and disconnected. She will come back. Okay.
Sir, I have a question.
Yes, please.
So it's not related to the topic, but it's about the electrical thing, sir. So like usually, like say suppose like you have a normal plug, no, sir. Say if the
Hmm.
plug is like broken. I've seen my father or like people, electricians, they like cut off the wires. They cut off the wires and they just put it into the socket. How does it not catch on fire, sir? Because isn't the wire exposed? Like it doesn't have any insulation around it, and they just put it in the socket.
Okay. So your question again. Say it again, please.
For example, so for example, like say suppose you have like a plug like this, and like
Yeah.
the top part here, it's broken. I've seen
Hmm.
electric. I've seen people or my father, like the wires inside this node, they'll cut it even more so until like it becomes sharp or whatever, and they just put it
Hmm.
into the socket. How does it not catch on fire? Because isn't the wire exposed? Like it's exposed, doesn't have
Yeah,
any insulation.
it can cause. Okay, it is not causing because basically what happens. There is some scenarios people using these types of things. Okay, and because of the loose connection, the sparks. Like we know that when there is a loose connection with the socket and with the naked wire, there will be the spark generation, like tuck tuck tuck, something like. And if it is continuously generating, it may melt the switch, it may melt the wire, which can cause the fire. Wow, it's a rhyme. So basically, what I'm trying to say that the naked, why they are doing naked wire? Because so that the current, which is now the plug is not working. The plug which is used to send the electricity through the laptop, it's not working right now. It's they cut it so that the direct current can go. Okay, so it can be good for a temporary way, but always use plug. Don't use these things because it can cause fire. If it is heavy load current, then it definitely will cause fire. It is low, like small lights you are using, then it can be good, but still recommended is used to use plug. Yeah, okay.
Okay, sir,
Yes,
thank you.
Abigail. Yeah. Did you understand, Abigail, this concept? No.
Yes, I understood.
Pakka?
Yeah, tha pakka.
Okay, next doubt, please. Yes, Abigail, next doubt.
Next doubt is on page 365,
Hmm.
the example 16.1.
Okay, so yeah. So I told you, Abigail, that the charges occur because of what? Yesterday only I taught this. Okay. So basically, what happened? I told you the by the rubbing. Okay, Sam will tell me. Sam, by the rubbing, what happens to the object? How it becomes charged?
Because the electron passes on.
Electron passes from one object to another object. If a body loses the electron, it becomes positively charged. If a body gains the electron, it becomes negatively charged. That's how the charges occur. Na? Understood? So basically what happens, like this is a body, it has some charge. Remember as q. So there is a formula for finding how much charge is there. So the q is basically n into e. There's a formula, q is equals to n into e, where q is the charge on a body, q is a charge on a body N is equals to number of electrons and E is the charge of electron. E is what? Charge of electron, which is always fixed, which is 1.6 into 10 to the power minus 19 coulomb. Okay. So, like if two electrons are transferred from one body to another body, for example, if one question is like this, one question is like this, like two electrons are transferred on this body. Okay. So, how much charge is there? So, we know the formula Q is equals to N into E, where N is basically 2. Yes. And E is always fixed, which is 1.6 into 10 to the power minus 19 coulomb. So Q is equals to 3.2 into 10 to the power minus 19 coulomb. So the charge on the body will be this much. Understood, Abigail? If 7 electrons transfer, this much. 10 electron transfer, this. We'll have to multiply it with the 1.6. Understood, everyone?
Yes, sir, understood.
Okay, now in this question, guys, see, the body has one coulomb charge. The body has 1 coulomb charge. So, for example, this is a body and it has 1 coulomb charge. So we know Q is equals to N into E. We have to find the number of electron. Like how many number of electron makes the body 1 coulomb charge? That's the question is saying. Yes, how many number of electrons makes the body 1 coulomb charge? So it is given as 1, and we have to find, and E is always fixed, which is 1.6 into 10 to the power minus 19 coulomb. Now it is multiplication, it will go and become divide here. So it will become 1 upon 1.6 into 10 to the power minus 19 is equals to N. Did you understand, Abigail? No.
Yes.
Okay. So now what will happen? The minus power is there. It will go to the numerator, it will become positive power. So it will become 1 upon 1.6 into 10 to the power 19. Okay. Now this will become 10. So it will become 10 upon 16 into 10 to the power 19. And so it will become 0.625 into 10 to the power 19. And so 6.25 into 10 to the power 19 N. So it means that this much electrons are needed so that the body can possess 1 coulomb charge. Did you understand? No, still not understand.
Hmm. Sir, how did you remove the decimal?
How did you remove the decimal? See, 10 upon
Yeah.
1, sorry, just give me a second. Yeah, 1 upon 1.6 is given. Okay. Now, basically, if 3.2 is there, so how will you write? Like point you will remove, and because after point only one digit is there, so in denominator 10 will come. So the new number will become 32 by 10. Yes or no? Huh? In the same way, if denominator has a number with a decimal, you can remove this, and in the numerator it can become 10. So it becomes 10 upon 16. Like vice versa, we did with the numerator one. Na? Numerator is 3.2, and then we removed the point and the 10 came in the down. Do you understand? No. Ask me, ask me.
No, I still didn't understand.
Okay. So, for example, we'll take this. For example, 2.4 is given. Yeah, yeah, 2.4 is given. So, how will you write in the form of fraction?
24 by 10.
Very good. And if 1 upon 2.4 is given, then how will you write?
1 upon 24 by 10.
Okay. So you can write like this also, 1 upon 24 by 10. So can I write it like this? 1 divided by 24 upon 10 because it's a division sign, no? It's a division sign.
Yeah.
So can I write it like this?
Yeah, sir.
Now, to change the division form, it will become 1 into, so the reciprocal will occur. So it will become 10 upon 24.
Yeah.
That will become 10 upon 24.
Okay, sir, got it.
So this is how it becomes. So instead of doing this whole process, we simply remove the decimal and 10 will come in numerator. Like that.
Okay, sir, got it now.
Okay. Yes, Jehoad.
Sir, yesterday when you showed us the formula, you said it as 6.25 raised to, times
Yeah.
10 raised to minus 18 or minus
Sorry,
19.
sorry. No, not minus 18. It was plus 18. Not minus. Minus is not there because the power become positive. Na? Like minus 19, when it go to the numerator, it become plus 19. No? Did you understand? That's why. The minus power, when it go to the numerator, it become positive. Did you understand? No. Yes, Abigail. Please.
No, sir, it got on unmute by mistake.
Huh?
It got on unmute by mistake.
Okay. Any more doubt? Please ask me. Everyone. Sam, do you have any doubt?
Sir,
Yes, Jehovah.
is it possible to write 6.25 into 10 raised to 18 as 625 into 10 raised to 16?
625 as 10 to raised to power 16, not 18. Like you can like for example, two decimal places is going to the right side, no? So you have to subtract two power. So 18 minus 2 is 16. So you can write like this: 625 into 10 to the power 16. Do you understand? No. No. Understand? Yeah. Next, Abigail, please ask me. Ask me.
Yeah, sir, I'm just looking through which are my doubts.
Mm-hmm. Sam, you don't have any doubt? Jahan, please tell
Yeah,
me
sir.
now which
Sir,
chapter we have to
column.
complete. Yes.
Sir,
Yes,
how
please.
much is one column? It doesn't have a charge, sir. I forgot. Column is for what unit?
Coulomb is charge.
A star.
Like
Okay.
1 coulomb charge, 2 coulomb charge, 3 coulomb charge. Coulomb is always charge.
Yes.
Yes, Abigail.
Sir, in page 364,
Mm.
in the top, it's written U is equal to small k, capital
Mm.
Q, small q divided by R. What does
Mm.
U stand for?
Okay, U stands for potential energy. Okay, U stands for potential energy. Okay, for example, now what do you mean potential energy? So, for example, this is a box. Yesterday, I took an example of your beloved phone. Okay, you took a beloved phone and you just drop it from this height, so it won't happen anything. Okay, but if you will take the beloved phone and if you will drop it from your rooftop, then the phone will drop, phone will broke, and then mama will broke you. So basically what happens, the potential energy is the energy possessed when we are doing some work. For example, we are doing the work from here, like from the gravity, the work is from here. It won't have that much energy. But when we are taking the rooftop and when we're dropping from the rooftop, then there's a lot of potential energy which is occurs. So in the same way, in this case, the KQ. So we can understand it like this. There are two charges. Okay. Now, for example, we can take this is positive charge and this is negative charge. So they have force of attraction. They have force of attraction. So my work which I'm doing, which make them to move away from each other, that work is now stored in the form of potential energy. For example, two magnets are there. These are the two magnets are there. Now, when I am taking them away, I am doing some work against the magnetic and attraction force. Yes, I am doing some work against the magnetic attraction force. So when I'm moving them away, I have to do some work. When I will leave it, it will again come and it will stick. Understood? It will come and it will stick. So this is what potential energy is. This the work done against the charges of attraction, and if it is repulsion, like for example, if they are repelling, so I am doing some work so that they can attach to each other. So that is the force of that is potential energy. Understood now?
Yes, I got it.
Okay. Yeah. Next, please. So basically, the V which is stands for potential, electrostatic potential, basically it's the same thing. Okay. So for example, you can take this is a Q charge, like positive charge, and this is small q charge, a negative charge. Okay. So when I am doing some work, okay, to we can take both as positive charge so that it won't be confusion for you. So this is also positive charge. Uh-huh. Okay. So they both are positive charge. Now, when I will bring near to this, I am doing some work. I'm doing some work. Okay, I'm this is like this is positive charge and this is positive charge. So I'm doing some work because automatically they won't come because both are positive charge. They both have repulsive force. Automatically they won't come. I have to do some work so that they can come near. So the work done by me to bring the charge Q to the another charge Q is basically electric potential. Is basically what? Electric potential. So the work done to bring a charge from infinity to the another charge is stands for electric potential, where V is electric potential. V is electric potential. W stands for work done, and Q stands for charge, the charge which I am bringing. Understood? No. Did you understand, guys? Abigail, Jehovan, everyone.
So charge is always in coulomb.
Yeah, charge always in coulomb.
Okay.
So now, with the help of this, you can solve this question also. Like for example, this question which I gave just now. That calculate the work done of bringing 3 coulomb charge across to a points of electric difference 24 volt. So we know that electric potential is a unit of volt. For example, 2 meter 7 centimeter, like this. No, in the same way, 2 volt is the electric potential. So the volt represented by V. Okay, so it is given that 24 volt and coulomb is 3 coulomb. So we know that V is equals to W upon Q. Now W is given as 24, Q is given as 3. When you will divide it, you will get answer as 8. So it means that 8 joule work you need to do. No, it's not 8. Sorry. V is basically 24 equals to W is W, Q is 3. It will go and it will multiply. So 24 into 3 is basically 72. So 72 joule of work you need to do to bring a 3 coulomb charge. Understood? Yes or no? Everyone understood, guys?
Yes, sir. So V is the potential difference and U is the potential energy.
Yeah. Electrostatic potential is V. And if, like, for example, now we understand it like this. Today's topic was like that. So for example, this is one point and this is another point. Okay. So for example, we'll take a cell. Okay, cell. So cell one has 9 volt and another has 0 volt. So charges always move from positive to negative. Okay, the electricity always moves from positive to negative. So the where the electricity will go from this to from high concentration to the low concentration. Okay, from high concentration to the low concentration. Na? So basically, the potential difference is defined as the difference between the two potential. For example, if it is 9 volt and it is 0 volt, okay, so what charges will try to go because electrons wants like now they become charged. Now, if I will touch them again, if I will touch them again, what will happen? They both will get neutral. Why? Because of by touching the excess electron which went from this body to this body. Now they when you will touch it again, they become neutral. Understood? For example, two electrons are transferred from this body to this body. Now this has two electron extra. When I will touch it again, the two electron which was extra in this, now it again went to this, making it neutral. Understood? So when there is potential difference, then only the electricity will flow. Electrons are moving now. When it has two electron excess, then it's only moving. Okay. If it is no two electron extra, then it won't move. So in the cell, if there is a potential difference, if there is a difference in the charges, then only the electricity will flow. Like cell, you know, clock cell has a like there are 5 volt battery, 9 volt battery. Why it is given as like that? Because they have electric difference between the positive terminal and the negative terminal of 9 volt, and after some time the cell will dead. Why the cell will become dead? Because the difference between them is now becomes same, like 4 volt 4 volt. Now there is no flow of electron, no flow of electron, then the cell is dead. Understood? No.
I kind of understood, sir. Can you explain one more time?
Okay. For example, see when there is a when like for example this is a cell. Okay. So this is positive terminal and this is negative terminal. Okay. Electricity usually like when you will place a cell, like if I'm placing a cell to to just turn on the bulb, so what will happen? The bulb will turn on. How? The the charges will move from positive terminal to the negative terminal. Yes, this is the way. Okay. Why it's moving? Because this positive terminal and this negative terminal, they have a difference of 9 volt. That's why it's moving. Okay. So for a suppose this is 9 volt and this is 0 volt. Suppose that's why we are getting 9 volt as a difference. Now, after sometimes while using the bulb, after sometimes it become 8 volt and it become 1 volt. So what is the difference between them now? 7. 8 minus 1, 7. After sometimes now it becomes 6 and it become 2. Then no, it become 3. Sorry. It become 3. Now 3 difference is there.
Yeah.
After sometimes it become 5 and it become 4. 1 volt difference is there. After sometimes if it become 4.5 and it become 4.5, now no difference is there. Now because no difference is there, the charges will not flow and the cell is dead.
Okay. So potential difference is measured by volt.
Yeah, potential difference is measured by volt.
And it's denoted by V, capital V.
Yeah, capital V.
Okay, sir. Now it's much more
Okay.
clear. Yeah.
Okay, so we'll stop here only. Okay, because the 11:30. Yes, Jahoan. Yes, Jahoan.
Sure. If it's like this, how does a rechargeable battery work?
Yeah, this is how battery works. When the both the potential difference is same, na, the cell is dead. And rechargeable, how rechargeable work? We have to plug into the electricity, which makes again potential difference. Which again makes potential difference. Now again potential difference makes, like, for how the rechargeable works, like it will the potential which are the same, now they will make again the potential difference of 9 volt. Again the electricity, the cell will start working. Understood? No. This is how the electricity, the cells work. Okay, so we'll stop here only. I hope you enjoyed the class. Till then, bye. Have a nice day. Signing off. Tata bye bye. Shabake. Sayo. Nara.
Thank you,
Bye,
sir.
sir.
Bye,
Thank you,
sir.
sir.